Hey there, Algebra 2. In this video, we're going to be reviewing how to simplify expressions. And in algebra, we have both numerical and, of course, algebraic expressions. Numerical are those that involve only numbers, and then algebraic would be those that involve numbers and variables. So we'll start out with just numericals here in the first few examples. And in order to simplify these types of expressions, you need to know your order of operations. In case you've forgotten, here is a reminder of how you go through and go through the order of operations. You always start with what's inside grouping symbols, parentheses, brackets, braces, and fraction bars are actually considered grouping symbols as well. Then you move on to any exponents or square roots you might have in the expression, and then it's always multiplication and division from left to right, followed by addition and subtraction left to right. So let's go ahead and try a few of these just to get our brains working. Number 1, so we have 29 minus the quantity 11 minus 2 cubed plus 6 squared divided by 4, and my order of operations say I need to do what's inside my grouping symbols first, so I'll do 11 minus 2 cubed, and 2 cubed is an exponent, so we'll go ahead and simplify that as well. That is going to give us 8, 2 times 2 times 2. So we'll bring everything else down. And 11 minus 8, that's still inside grouping symbols, so we'll go ahead and make that 3. So we have 29 minus 3 divided by 6 squared plus 4. Now we can also simplify 6 squared in this step because simplifying this doesn't really change the fact that we have a minus 3 here, and exponents come next anyway. 6 squared we know is 36. So this is 36, and this should be a plus sign, not a division sign there, divided by 4. So now we move on to, we're done with our exponents and our grouping symbols. We do multiplication and division left to right. I don't see any multiplication here, but I do see some division here at the end. 36 divided by 4 is 9, and there was a plus sign in front of that. So we have 29 minus 3 plus 9. And now it's just addition, subtraction left, so we just work left to right. 29 minus 3 is 26, and plus 9 is 35. Number 2, we have 7 minus the quantity of the absolute value, 10 minus 12, plus 5 squared, all divided by 9 minus 2 squared. Fraction bars is another example of grouping symbols. So when you see a big fraction bar like this, you do the numerator all by itself first, and then the denominator all by itself. So in the numerator, we have 7 that we'll leave alone now, minus, and then we have some grouping symbols here. We can do our absolute value first. We have 10 minus 12, so that's going to give us negative 2 inside absolute value bars, plus 5 squared. Well, 5 squared is 25. I can go ahead and simplify that exponent too, since again it doesn't affect what's over here in my absolute value. And that's all divided by my denominator. I have 9 minus 2 squared. Well, 2 squared is 4, so we'll go ahead and make that 9 minus 4. Okay, below that now, 7 minus the absolute value of negative 2 is 2. So this is going to be 7 minus the quantity 2 plus 25. All over 9 minus 4, which is 5. So our denominator just becomes 5. So now we have 7 minus, well, 2 plus 25 is 27. So this is 7 minus 27 all over 5. 7 minus 27 is negative 20, so this becomes negative 20 all over 5, and negative 20 divided by 5 is negative 4. So negative 4 is what that simplifies down to. Okay, I want you to go ahead and pause the video, and I want you to try examples 3 and 4 on your own using your order of operations. Once you've completed both those examples, click play to check your answer, please. Alright, let's go ahead and check what you got for examples 3 and 4. So you can see in the blue and the purple and the red is what I did in each step to simplify using my order of operations. So number 3, you should end up getting an improper fraction answer of 29 fourths. Make sure you reduce all fractions. You don't have to make them mixed numbers. Make them improper, that's okay, but make sure you have them reduced in your final answers. And then number 4 here, same thing. You can see in the colors what I did in each step, and you get down to a final answer of 4 if you do that correctly. So compare your work against my own, and then if you had trouble with either of those, be sure to jot that down and ask me in class the next time we see each other about that. Okay, moving on to algebraic expressions. So in these next few examples, we're going to practice evaluating algebraic expressions. And all that means is I'm giving you values for the variables in the expression, and you're replacing the variable with the value I give you. Once you do that, it is the same thing as what we did in 1 through 4. It's the order of operations again. So 5 here, we have a times b squared all over c plus 12. And I'm telling you that a is 3, b is negative 4, and c is positive 8. So we'll go ahead and we'll replace those variables with these values. So that gives us 3 times negative 4 squared. Anytime you're plugging a negative into a power, make sure you use your parentheses. Okay, you have to have a negative or parentheses around that negative 4, excuse me, so that you apply that exponent of 2 correctly to the negative 4. And then that's all over c, which is 8 plus 12. So once that all gets plugged in, now you can use your order of operations, and we can do the exponent up top first. So that's 3 times negative 4 squared is 16, because a negative times itself is a positive. So 16 all over 8 plus 12 is 20. So we have 3 times 16 now, which is 48 over 20. And that's just going to reduce down to the improper fraction 12/5. Okay, number 6, we have negative x squared plus 7 times the quantity y plus 2 minus 1. And I'm saying that x is positive 5 and y is negative 9. So for this problem, notice the negative on the x squared is in the problem originally. Okay, I'm not telling you to plug in a negative number for x. It's already there, so we're going to keep that. Then we'll do our parentheses around the positive 5, because that's what I'm plugging in for x, is just a positive 5. So it should look like that. Plus 7 times the quantity, negative 9 is y, plus 2, and then we have that minus 1 at the end. Okay, so when I do my grouping symbols here, negative 9 plus 2 is negative 7. And then we have a 7 out in front of that that's being multiplied by that negative 7. This minus 1 at the end here. We can go ahead and do this exponent here, but be careful. I'm not squaring negative 5, remember. I'm just squaring positive 5. So positive 5 squared is 25. But then there's still that negative sign out in front. So that keeps this a negative. So this is a negative 25 here. So now we have negative 25. We have multiplication next. 7 times negative 7 is negative 49 minus 1. Negative 25 minus 49 is negative 74 minus 1, which gives us a negative 75. Okay, number 7. For this one, I have 3r minus 4s. R is 5 and s is 2/3. So we're going to take 3 times 5 minus 4 times 2/3. Well, 3 times 5 we know is 15. And then we're going to be subtracting 4 times 2/3. Well, 4 times 2/3 is going to give us 8/3. So this will be 15 minus 8/3. Even though you have your fancy calculators, you should be able to do this without a calculator. 15, okay, is going to be the same thing as 15 over, or excuse me, is 45 over 3. And then minus 8/3. Remember common denominators when you add or subtract fractions. So this is 45/3 minus 8/3, and that's going to give us 37/3. 37/3. Okay, number 8, we have the absolute value of x squared minus y squared minus x times y. And x is negative 6, y is positive 8. So we'll start with our absolute value bars. We're going to do negative 6 inside parentheses squared minus positive 8. So we need that minus sign here outside of the parentheses. squared minus x, again, negative 6, times y is 8. Okay, so inside our absolute value bars, negative 6 squared is positive 36. 8 squared is positive 64, but there's still subtraction in the middle. And then we're subtracting on the outside, negative 6 times 8. Well, negative 6 times 8 is negative 48, so we have a minus minus on the outside, which will change here in the next step. 36 minus 64 is a negative 28, inside absolute value bars though. And then minus minus always means plus, so this is really plus 48 on the outside. So the absolute value of negative 28 becomes 28, and when you add 28 to 48, you get 76. Okay, same thing as last time. I want you to pause the video now and try 9 and 10 on your own. Once you have both of those done, click play and check your answer with mine, please. Okay, check your answers. Again, number 9 here, I plugged in a 2 for W and an 18 for V. And you can see down here my steps. You end up getting an improper fraction of negative 32 thirds for number 9. And then number 10, plugging in just a 1/4 for M. You have to do a little bit of fraction addition at the end, and you should get a reduced improper fraction of 19/8 for that answer. And again, if you had trouble with those and can't see where you made your mistake, make sure you make a note and check with me the next time you see me in class. Okay, last few examples. We're just going to review how we simplify algebraic expressions when there's no value to plug in for a variable. So that's what 11 through 14 are going to practice. And if you remember, we simplify variable expressions by doing two things: distributing and or combining like terms. So number 11, I can't distribute all for number 11, but I can combine some like terms. I have a positive 16x and a negative 7x here. That when you combine those, you get a positive 9x. And then negative 11 plus 10 is negative 1. So this expression simplifies to 9x minus 1. Number 13, I do have the opportunity to distribute, so I always do distributing first. This is going to give me a plus 6n minus 14 when I distribute. And then we'll bring down the 13 and the positive 19n. After you distribute, that's when you go through and you combine your like terms. So I see a 13 and a negative 14. That gives me a negative 1. And then 6n plus 19n is a plus 25n. So we have negative 1 plus 25n. Or more often than not, you'll see that written as 25n minus 1. Normally we like to put our expressions like these in standard form, so that means that the variables come first and the constant, the negative 1, would come second. Okay, 13, we have 3 times the quantity 3a minus 5b minus the quantity a minus 7b. So I'll distribute this 3 here to get 9a minus 15b. And then the same thing over here, we'll distribute this negative 1, is what that negative sign there means. So that gives us a minus a plus 7b. And then when I combine my like terms, I have a 9a and a negative 1a. That will give me 8a. And then I can also combine my negative 15b with my positive 7b, and that will give me a minus 8b. So 8a minus 8b. Okay, one more time, pause the video, try 14 on your own, and then click play to check your answer. Okay, so the same process for this one. We'll distribute our negative 8 and our negative 3 first to get negative 16x minus 8y plus 15x plus 6y. And then when we combine our like terms, we're left with negative x minus 2y for our answer. Alright, if you had any questions over this video, as you're always supposed to do, make sure those are written down so that you can ask those the next time you see me. And until that time, have a nice day. You're all wonderful people. Take care.